Okay, guys, here we are. Um, like I said, today we're gonna keep working on the iGEM software uh, project for the 2025 team. There are a few issues already in GitHub. However, I think we're just gonna keep working on the API because this was where we're currently at. And if we look at the iGEM 2025 judging handbook, so yeah, to everybody who doesn't know this, we are going for the software special prize. Let me just quickly open that in the browser so you can see. And the special prize requires, if we go to, where is it? Special prizes, software tool, page 83. Okay. Requires these six, like has these six requirements in order to potentially win, or these areas that you should focus on as a team. Now, we can go through them and see what we are gonna have to do today. So, how well is the software compatible with, and does it leverage existing synthetic biology standards? So, data formats we've got covered. These other two, to be honest, they don't really apply to this project. Simply because RFCs. So I hadn't actually heard of this before we we looked into this. Huh. I have apparently just opened Copilot. I'm trying out a new keyboard today, and it's not made for Windows, it's made for Mac, so I'm gonna have a bit of issue when it comes to using the shortcuts properly. Let's see how that's gonna go. Synthetic biology, yep, there it is. So yeah, I looked into this, and the thing about this is, it's like the RFCs for the um, whatchamacallit, yep, Internet Engineering Task Force. And the thing is, they have recent submissions, right? But the last recent submission is from 2017. So this honestly seems kind of dead. And if we check out, where was this? All submissions. I mean, we can also, you know what, we can just filter by author, and if we show all of them, we can see that. Oh, this is not what I was looking for. Where is it? Hmm. Anyway, so it was like something around 70, 76 RFCs in total, which doesn't make me think that this is something big. Um, and also, like, what we're introducing is a software application to make the lives of anybody working with Mesa easier, not introduce a completely new standard or change anything. In that regard, yes, this has great applications and great potential, right? It's a very cool software in my opinion. However, it doesn't require any of this. Data formats, yeah, absolutely. So downloads are since last weekend, I think. Now in GeneBank format, which means they integrate very nicely with Genius and other like synthetic or just sequence annotation or sequence creation software. So that's very good now. We've definitely got this covered. This tool is easy to integrate with other stuff, and in terms of input and output, if you input, you can upload your custom sequence. You can do whatever you want pretty much on that front. There is one more issue which we will try to get to. Where is it? Yeah, Minecraft. There's a Minecraft collab notebook. Minecraft collab notebook where anybody can use Minecraft, and if you don't know, Minecraft is pretty cool. Check out the GitHub repo. Minecraft essentially uses AlphaFold iteratively to create a de novo binder for whatever you upload. And so this is obviously great for your Oh, sorry. for Mesa, because if you can create a few binders which can bind on different epitopes of whatever you're trying to bind, then this is super useful for especially this purpose. Yeah, really cool tool. Should definitely check it out. And so yeah, either we're gonna link to the GitHub repo or we're just gonna directly link to the notebook for people to create their own binders. Oh, Minecraft tutorial on Rosetta Commons. Interesting. I mean, why not, right? Yeah. Okay, so going back to this though, the experimental validation of the software. We want to do it. We have worked on sequences and plasmids to do this. However, it's not currently in progress because we still need to order the gene blocks, the G blocks. However, we don't know from what company we can order them. There's a bit of an issue right now because we only have so many nucleotides left with IDT. So we hope that we can be sponsored by Twist to finish this final part of our experimental projects in order to hopefully validate this software experimentally. Otherwise, there are a few other routes we can take, but this would obviously be the best. Can the software be useful to other projects? Absolutely. I mean, Mesa is incredibly versatile. It's designed to be compatible with anyone, with anything, and usable by anyone. You can have it intracellularly, you can have it bound to a membrane, and so this is absolutely useful for that purpose. Now, I don't see what else you would say other than input and output are easily integrated with other tools due to the common formats, and Mesa is super useful to other projects. So yeah, definitely a big check mark right there. Which transitions nicely into the next point, which is also what we're going to be focusing on today. How well can the software itself be integrated with external tools / software applications? So as you guys know, up until recently, most of this project was a Streamlit web application, which is really nice. It looks cool. It's easy to use, very easy to use in my opinion. But it doesn't, programmatically it's horror. It's absolutely horrible. You would have to write your own, like, what you call it, state session thing in order to use the website, which, might as well just integrate an API. So that's exactly what we did. And we will also build a Python package around it so that you can integrate it into Python applications without having to host the Docker container at all, which that obviously is the best possible scenario for this. So we're already kind of done with this part. We will try to get this done as well in terms of create a Python package so that you can have, classes, and you just add stuff, and internally it keeps track of what was added, what sequence this was, and then you can just easily get a gene bank file out of that. I think that's the best way to go here. Is the software user friendly? So I think so, and from the tests that we've done with other people, we do also think so. Actually, now that I'm thinking about it, might not be a bad idea to just show this to a bunch of people and see what they think. Yeah, you know what? I'm gonna write that down right now. Do that. We have access to a lab with many other scientists working there, so we will definitely show this to people who might actually use this, especially because they're all also focused on synthetic biology, and they know Genius, etc. So this is something that could be useful to them. Okay, software right there. I'm currently just writing in our team Slack channel, specifically focused for like the software channel, to get like this written down and share this idea with others and see what they think. All right. How well is the software written and documented for future groups to extend and improve? This could include code documentation, comments in the code, performance evaluation, architecture diagrams, installation, and execution scripts. Yeah, I think we already covered this a few times now. Execution and installation scripts, easy. We've got Docker containers. We've got just the Git repo itself can be run. So yep, this is super simple. If you go to Docker Hub and you check out the Mesa Designer, search for Mesa Designer, find it. There it is, the very first one. If we check these tags out, 109 pulls, that's crazy. This is, yeah, we've got a bunch of different versions. We will make more available where it's like focused on just API, just the tool combinations, etc. I don't think the Python package inside the Docker container makes all that. My guess, maybe it does. Yeah, anyway, okay, yep, this is, yep, we've got, well, we definitely have that part covered. Architecture diagram. We might actually get to making this today. Let's see. Performance evaluation. So what I've got, like, I have an idea for performance evaluation. First of all, we can do a few things there. We can just start it up, see what like load is on the system. I think that's an important criterion, because Streamlit isn't the lightest framework to use for building a web application. However, it looks really nice. It's easy to understand what's going on in terms of code. It's easy to extend. There's a very large community around it, creating more content for it. So if other teams want to keep improving the software in the future, it's very, easy to do in terms of that. However, it's not the lightest on the OS. So that's definitely an important part. However, we can definitely show that through the commits, we've done major work to improve performance. And I think that's where I'm going to do this performance evaluation part. The second part could be focused on the output, like see, performance as in user experience, kind of. I don't know. Let's see. But the going through the the individual commits and seeing how important performance has like changed or improved, hopefully. Well, I know it's improved. Is going to be interesting. Comments in the code and code documentation do not exist right now. Have to be done, because right now this code is, it's Streamlit. It's easy to understand what's going on in terms of UI and front end. However, the actual state management is a nightmare, because Streamlit is not, like the state management is kind of different for a few different types of components. So a button has different state management than a toggle or a text input field. And so this is not in itself difficult to understand, but this is a 1,400, I believe, lines of code thing right now, where some of it is UI, some of it is functionality. So yeah, there's definitely a need to either, or actually do both, pick the functionality from this and separate it out into functions, which then have a functional purpose, and separate the UI components and also document this stuff so that it's easy to actually get it to. Yeah, but for now we're gonna continue work on the API. There's already a lot there. Let me just quickly start up the container, and then we can. Oh, that was outside. I was very confused there for a second what that horn was. And then we can check out the API documentation. We're using Fast API for the API just because Fast API is really nice. So if we check that out really quickly, go to docs/docs, you can see that we've already got quite a bit of functionality. However, if we do compare that to, guys, I got an answer in the chat. Let's see. Sure thing. We wanted to post on Wednesday, but I need your input on. Yep. Okay. Let me just quickly reply to a few messages in our Slack, and I'll be right back. Okay. Actually, you know what, guys? I think you can go through this with me. So let me just quickly grab this image. This is the current idea for the stream announcement post on our social media websites. Okay, yeah, stream, sure. Want to learn and see how we develop our software live? That makes sense. Join our live stream on YouTube and watch our bioinformatics team code and join interactive space to learn about. Yeah, I like that. Biology lover. What? Best stream ever. Ah, that's pretty cute. I like that. Yeah. Time Monday. Okay. Yeah. So let's just write her an answer. Point 1. So I think the first XXX could be MESA receptors. Point 2 could be I guess iGEM work. Yeah, I think that's probably good. Also, I would add maybe in the bottom section next to user, add platform YouTube. Okay, wonderful. The time is 11. We'll see. Maybe we're a bit earlier tomorrow, but I don't think so because this seems like a good time. All right. Going back to this stuff. So if we just quickly pull up the actual Mesa design tool, just start that Streamlit, run app main. You can see that if we go through the step by step, there's quite a big difference. So yeah, okay, this is obviously like the first part. This gives you access to the database that we've compiled from other databases such as SubDAP and Scampi. Thank you very much for making all of that data available for free, I might add. And this will return almost the exact same thing as this, except like this has a bit more data. Because obviously, like, this makes sense. If you search for something using the API, you probably want to have a bit. Oh, interesting. Found an error already. Wonderful. Okay, what's the problem? Oh, it seems to be a type error. If I'm not mistaken. Let's check that out really quickly. Yeah, it's a type issue. Okay. Then let's just quickly check if that's really the case. If we remove the type at all, like go completely, reload this, reload the website, search for progesterone. Perfect. Okay, yeah, you can see there's a lot more data in here than there is in the Mesa Designer tool. We filter a lot of columns here completely, and we also filter a lot more data because it's not that useful to people. However, if you're doing programmatic stuff, there might be a machine learning application purpose. So yeah, we don't want to hide any data that you might need for that purpose. Okay, you go on, you can select a PDB. The equivalent of that in the API is, like, there are a few options. You can get the separate chains as like extracted by our tool. You can get the entire structure or FASTA file. All of this works on the RCSB database. As you know, recently we made the switch from downloading all of that data, all of these structures locally, to having them up in just pulling them down from RCSB. Because in terms of time, yes, it's a 10x difference. However, it's a 10x difference from 0.2 seconds to, or like 0.02 seconds to 0.2 seconds. And this does make a difference, but not significantly, and this makes it so much easier for so many more people to run. I don't think it really is necessary to have any downloaded structure files. Yeah. However, we do give you this option here. This is a bit easier maybe than writing it directly. However, obviously this is like you have two requests, once to this API and then to the RCSB API, also 2 replies, so it's like twice as long in theory, which isn't great. So I don't recommend these, but they are available if, say, you want to build your application entirely around this API and you don't want to have any other APIs necessary, then this will just do that for you. Generate chain selection. So this just extracts the residues from your selection from a given PDB file. Yeah, I mean, we could go through all of these, and we will in the tutorial videos, but not right now. But as you can see, this is yeah, a nice documentation as you're used to for APIs, and we can just scale this up a bit. Yeah, okay, never mind. I guess this is best for stream. All of this is available in the latest GitHub releases and also in the latest Docker. If we check that out again, actually, I think we might be faster if we go through this link. If we go have a look here. Oh, I got a reply. Yeah, so 3slim beta. If you check out GitHub, we have pre-release information. This now includes the API. On 2 separate ports is where you'll find the application, and then also the API on port 8000. Yeah, very easy to use. However, let's keep going. So for right now, we are capable of creating thread sequences. We are capable of attaching a cargo, attaching an AIP, PRS. In this attack cargo, you can also decide to create a PRS sequence if you wish to do so while attaching the cargo. You can get an overview of different stuff that's available from different papers. They always supply the sources also for this data. If we check this out, you can add your protease entirely. You can attach a split protease. Maybe we should rename this to attach split protease. I think that makes more sense than just attach split. I know it's not, the biggest difference, but I think it might be useful for people who, don't know that much yet. Split, I don't know, should we call it split protease or split, whatever, because in theory you could do whatever you want. No, I'm gonna say protease, split protease. Okay, change that name. We can attach TEV protease from pre-selected. TEV proteases simply by getting them first. You get an overview over the different TEV proteases, their DNA, and also protein sequence. Obviously, the DNA sequence isn't, like final. You can change that to whatever you need for your specific organism or application, in terms of GC content, etc. So, yeah, what we need to do now is make. So ideally you'd have one big request where you can do all of this at once. But in theory, so far, this I think, because you can do this stuff. In the API, you can do this stuff. This exists. Link sequences. So this is also where you have a bit. Where is it? Generate link chains. Yeah, here you also have a bit more flexibility than with the tool right now because you cannot select a custom linker right here. It always uses this, but you can change that when you use the API. You can do all of this. You can do this. You can get all of this overview in the API. Got another message. Let's check that out really quickly. Okay. Yep, you can. All of this is possible in the API right now. I'm just trying to see if there's anything that's not. Oh, detection tags. Yeah, we can add detection tags today. Sure. So, detection tags work pretty similar to thread sequences and also like attaching other stuff, except they go in the front. I'm just thinking if okay, so we're gonna start off by creating a new get request. Let me just share my IDE with you people so that you can see what this is, what this looks like. Oh yeah, I'm gonna have to rescale this 1 second. So I guess we're gonna make it just a bit larger. Okay, hopefully that works. All right, let's zoom in here so that you can actually see stuff. I don't think I've ever zoomed in. You know what? It's probably fine. Yeah. Okay. So the URL is gonna be oh my god. Let me just drink some stuff. I think this can also definitely go under extra slash tags or tag overview. Yep, this is probably good. Summary will be get an overview over select tags from synthetic biology. Yeah. So these tags are nothing special to Mesa. These are just, general tags that are used all over the place. Something like an HA tag or a flag tag, 3x flag tag, etc. Oh, you want to create a new function, tag overview. Or, yeah, I guess at some point this has to be, unified, unanimously named. Okay, this is also called overview. So that's fine. This doesn't take any inputs, and it should return a dictionary of strings as keys, and then values will be, oh god, what do we think we need? So I think we need a list of strings for the sources. Because these are very common, but still, we pulled them from a paper specifically, and so they might as well, be referenced. We need a dictionary of strings to strings for the names of the actual tags and then their sequences. However, I think we can go with a list of strings here again, just because they can return, it'll be HA tag and then it'll be the protein sequence and the DNA sequence, just, make it a little bit easier if you don't want to do that translation yourself. But if you do, it's, not that big a deal. Get an overview of available pre-selected, or, well, I think assemble available. That's a good word here. Yeah, tag sequences. commonly used. Available, commonly tag sequences. I think that's a good description. Okay, we now need to pull in this data. I don't know if it's already imported. Let's check that. It is not imported. Okay, we check over here. The data is tag seeks. And I think the return is going to be pretty simple. We just return a new dictionary of, well, first of all, sources. I want to just quickly check that this is always, yep, okay. I can just copy this. These are the same for this particular one. Okay. And then, yeah, I think it's just as easy as supplying the tag sequences as the value for the key tags. Okay, you are not happy with this. You got... Wait, this should be that. Yes. Okay, there we go. Nice. Let's reload this. It's already reloaded. Perfect. Can refresh the browser and check out what that looks like. And here we now have tag overview. If we try this, we execute it, we get... Ah, yeah, okay, I guess there aren't any nucleotide sequences available for these. However, yeah, I think that's fine. If we do decide to add them, they will be there. But I mean, it's not the biggest priority because usually you'll be interested in the protein sequence, or like, yeah, amino acid sequence, and then sorry, not protein sequence, amino acid sequence. Attach those and then put that into something like Genius, and then compile that to a specific organism's like requirements, I guess is a good word. The next thing we need is to actually be able to attach one of these. So for that purpose, we need a new pydantic model. You know what, let me just quickly collapse all of this. Okay. Show you what that looks like. Collapse all. There we go. Why didn't it? Oh, does it only do it? I see. There we go. Okay, we need a new class here. We will call this what do we want to call this? Maybe tag sequence input? Sure. This inherits from pydantic space model. If we check that up here, there you go. We need a sequences field. It's going to be just named that, and the description will be. Actually, we will also have an example. I think I can just take this from here. Yeah, this is exactly the same thing. So we just have that in the description. This is identical, almost identical. Just because they both do the same thing, right? They take the sequence and they add your sequence of choice. And let's actually call this tags plural. Although no, don't make it overly complicated. And then we have a tag sequence. which is another field which is called exactly that. Examples, we don't need an example. Description is just amino acid sequence of the tag to be prepended to all supplied sequences. Okay, why are you unhappy? Ah, you need a type annotation, that makes sense. You are a dictionary of string, and you are a string. Okay, now we can write the next endpoint, app.post in this case. We want a path which is /extra, /attach tag. Summary is going to be attach a supplied tag amino acid sequence. Oh, well, I guess we don't want attach, we want prepend. Prepend supplied amino acid sequence to all provided whatchamacallit sequences. Oops. We return a dictionary of string. Oh, this is the wrong line. This is not the function definition, sorry. And then we want an async function. Get attached tag. This takes two parameters. This takes the tag. Oh, sorry. No, this doesn't actually. This just takes tag data, which is of the type that we created earlier, tag sequence input. And it returns a dictionary of string to string, sure. Also a dictionary of string. So what are these going to be used for? This is just going to be to show the user what they put in as the tag that was attached and also the sequences that were created. Generate sequences with the provided tag prepended to all supplied sequences. This is just very repetitive, but I think it makes sense to describe it clearly in every place where it makes sense. Just so that no matter what you're using, whether you're using the docs or whether you're going through the code directly, it is very obvious what everything does. I think, you can definitely have too much documentation, especially code annotation. However, in this case, it makes perfect sense in my opinion. And then what we need to do is we can just create I think we can just do this like this. We want to return a dictionary of tag sequence, which is, actually, you know what, let's do this. Sequences is tag data dot sequences, and tag sequence is tag data dot tag sequence. Just so it's easier to work with this down here. And then the result is going to be sequences, which is a dictionary where the chain ID is the key and the value is the sequences. Well, actually, no. We're going to do sequence plus the tag sequence in the front. Tag sequence plus sequence for chain ID sequence in sequences dot items. Yeah, perfect. Nice. Wonderful. If we save that, we can reload over here. That is looking good. We try this out. We have sequences and we have a tag sequence. If we just execute that, we get string sequence for chain A, string sequence for chain B. Perfect. Yeah, this looks good. Added that functionality. Okay. I didn't actually check before starting whether there are any new commits. There are not. Okay, good. that now gives us the ability to add tags, and that is actually it. So now comes the big part for the API, where I'm not sure how I want to do this. Obviously, right now you can assemble the thing yourself, and that's very good and useful. But I'm unsure of whether there should be like a download in GenBank file format thing, because I could see it being useful. However, you're already using this in a programmatic way, and so I don't know. So it's definitely going to be in the Python package, absolutely, but I don't know if it makes too much sense for the API, where you mostly just want to, access the data, attach stuff, do simple requests, but you're not gonna, or at least in my opinion, right now I don't see this as being one of the big use cases. Create the entire thing and then not know what you did, right? Because you're getting the data, you're looking at the data, you're deciding what you want to use from that data, and then going back, and adding more stuff. So yeah, I think this actually concludes the API for now. Which closes the API issue, which was issue number, I'm just checking, GitHub, number 42. Oh, nice. You can close that issue. Awesome. Oh, okay. Guys, I'm gonna turn off the stream really quickly because you're not supposed to see this. Okay, that is now invisible. I just want to be sure that you can't see this. I do not want to reveal my login information on stream. Let's just check that this is actually now not visible. Okay, that's good. Okay, 1 second. Two-factor authentication. Fun stuff. Okay, that worked. Nice. Yeah, okay. Here we are again. Turn that back on. There you go. Okay, we have closed that issue. Now we can go on to creating the Python package, which is, I think this is the really big part that we need to do. However, I'm going to take a short break and get something to eat because I haven't had anything today, and so should you. Drink some water. See you in a bit. Okay, we're back. I see we have some viewers, huh? Hey guys. So yeah, if you're still here, I would appreciate a quick message in chat so that we can I can see that, and then I will gladly explain to you what this is. If you're not familiar with iGEM or any of it, actually, for that matter. Okay. Oh, I guess not. Um, okay. Right. So. I think, yeah, earlier we said that today we want to get the Python package started. However, I'm just thinking about quickly adding the link for the custom binder creation to the Mesa tool. If we just quickly open this up. You can see here that, for example, if we were to search for something but we don't find anything, that we could then, so if we say, I don't know, blah, 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 that we then link to Bindcraft so that people can create their own binders. And then if they want to do this, they could then toggle something, and then it would supply the binder chains starting from this point right here, so that it only does the faucet preview, or I guess then it would be an input for every chain, and you could add your own binder there. Although I think, yeah, I guess actually we could just do chain A and B input, and we could skip from this part, so you would continue from this point on after this is linked right here. I think that would make sense. Okay, so let's do that. Going back to the IDE. We don't need this right now. We don't need this. We don't need this. We don't need this or this. I don't think we need this right now. This is fine, and we don't need this either. Okay. So what we would want is right here for the search field, where we have the search field, if this comes up empty, in this case here, we want to link to Bindcraft. So I guess we want and then we want to link to, so what do you think? Should we link to the GitHub or should we link to the Collab notebook? I think we're gonna link to the Collab notebook because most people can't run it on their personal system anyway, or won't. And if you already have it implemented on like a Slurm cluster or something, then you don't need the tool anyway. And then I think so. Yeah, I think the Collab notebook is going to be most useful. Minecraft Collab notebook, and this is actually a very nice notebook. This explains everything in great detail. So if we just do this, save that, reload the page, and we search for example, I know that there's nothing for LL37 in here. We can, yeah. Perfect, that works, nice. Okay, so this exists, however, if we go ahead and we don't find anything here, this won't exist. So in case this exists, I think there should be a toggle. We're going to call this custom binder. sd.toggle. Label will be custom binder. Value is definitely false. Oh, sorry. Key custom binder toggle, help, enter custom chain sequences for Mesa chains. These could result from a Bindcraft run. Okay. Yeah, I think that's good. Let's just save that really quickly, and we see the custom binder option now. Okay, now down here. All of this essentially ends in creating the linkers, or like creating the linked chains. So we can just create a new thing down here if this is not the case. So if you don't have any state.pdb results, or you have nothing selected, but the state.custom binder, what do we call it? Sorry, we forgot. Custom binder toggle, yeah. But the custom binder toggle is turned on, then we can go ahead and let the user enter their own custom chains. Now this should be pretty simple actually. I think the way I want to do it is either 2 columns or 2 rows. I'm thinking 2 columns. So we're just gonna say binder chain columns is sd.columns. We want 2 of those. And then with the first one, 0. Yikes, what's going on? We just create a new text input field. Chain a text input sd.text. Actually, we want a text area. That's fine. Label can be chain a sequence. Value will be empty. Height is going to be scaled to content. We have a maximum char limit of 5,000. I don't think we need anything else because we're just gonna immediately, if this exists, then the state dot chain sequences a chain, or chain A I think it's called, is just going to be this. So chain A takes input. Yeah. We can create the exact same thing for the B chain as well. B chain and B chain. Chain B text input. Okay. Actually, that has to be called that. All right. Now, if we save this, we turn on custom binder. We get 2 columns. Perfect. So actually, I think we can remove this check in all of these, because this should exist regardless of the states or the PDBs that were output by previous stuff. This is only dependent on the change that the user created in this step. So I think this is just a general improvement right there that we can make to all of this code. Now, and this one down here, yeah, so okay, we need to remember to remove this PDB download option if this is a thing, because obviously that won't work. Okay, save that, check it out. Say chain A, chain B, creates us the things. Perfect. Let's just go with extracellular meso, sorry. We do want the split chain design, customize those. We want a cargo sequence, which is just going to be called cargo, append that to chain B. We can create detection tags, maybe an HA and a 3x flag tag, why not? Let's see, okay, we have chain A tags. We have a signal sequence. We have the binder overview needs to be updated. Yes, this is incorrect. Let's see. In the overview container, binder FASTA display, we only want this if, actually, no, this is fine, but we need to assemble the state.pdb FASTA in case this is selected. So if state.pdb FASTA, if length of, I guess we can, just use these. If the length of this thing is greater than 0, then we want to say state dot, oh, actually, no, this is completely wrong, sorry. We just want this here. If that's the case, we clear state.pdb FASTA. And then we append the simple stuff chain A, followed by new line with the chain A sequence. Very simple. Let's turn that into an F string so we can just pump that in there. Chain A takes input. Okay, nice. Now we can go on to this exact same thing for the B chain. Except, actually, yeah, so the clearing part is going to be an issue. Let's just do this up there. Oh, dang it. Yep. If we do the custom binder, we clear FASTA. And then we don't have to do this down here. We can just say length if that is longer than 0, so if it exists, say.pdb FASTA plus equals the exact same code as above chain B, new line, chain B text input. Perfect. Okay. Nope. And we need a new line after this, and a new line after this. Perfect. Yes. Awesome. Now, will this work if we change it? Yes, perfect. Okay. We've got linkers, we've got TMDs, we've got the split protease, we have PRS sequences, and the cargo sequence, and we get this stuff. Okay, signal sequence, followed by the tag, followed by a binder, followed by a linker because we're doing extracellular MESA, perfect, TMD, and terminal protease, and the stop codon. Awesome. Yep, and this also looks good. Now, I'm going to download this really quickly and see what that looks like, if that is useful, because I could imagine that it actually, no, I think the only thing that doesn't work is the PDB download, but I guess, you know, since we're not even, we don't have one, this is fine. However, we can actually, yeah, this is a very easy thing. We can just disable the PDB download toggle if you have custom binder selected. Where is it? Is there, yeah, disabled is dependent on state dot custom binder toggle. Okay. Now if we reload this, yeah, perfect. And then also this can be true, but you know what? On change, we're gonna set this to false. So I think this is always now selected as true in the browser right now. However, we don't want that. We want this to be set to false automatically if the custom binder toggle is turned on. So here on change, create a new function for that. This doesn't return anything. And it will simply say, actually only do this if it already exists. If, So this is not going to be easy, because that part up there is run before this down here, and so that can cause issues with state. So if we just say, okay, this should be then not have this value, that won't work. We can try if this works. Custom binder toggle else false. Wait, this should be false if that. I mean, we could also just say not state. Let's see if that works. So I think we're gonna have to refresh for this one because this is a state change. Oh, I guess that still needs to be removed here. Okay. Right. Let's close that. Run it. Yeah, I see. Or we only want this if... Actually, should this just be an else? No. Yeah, we can just do this like this. Custom binder toggle in state and state.custom binder toggle. This way it won't error because, like, yeah, you might just, although it might not be bad to just be like, okay, no, I want a custom binder right from the start. So if this was an else instead, it would look like this. You could just enter it. I'm not sure what to do here. Let's see what this would look like. You would have custom binder sequence. And then here an st.subheader. Chain A. Chain B. So let me just show you what that looks like right now. So you could do this, and then if you search for something, it should disappear. But if you search for something that doesn't exist, you have the option to do custom binder again. Which now it doesn't make that much sense. No, let's go with the previous version. So elif custom binder toggle in Aldo. Huh, this is kind of... So maybe this custom binder thing should exist instead of the entire search functionality. Yeah. Then you would have this up here, and you could say, okay, no, I want the custom binder right from the start. Ignore target search, and then just turn that on, and all of this disappears. But if you search for something and nothing appears, you could also select custom binder, which yep, that's what I'm gonna do. We're gonna say elif state.custom binder toggle, and then we will move the custom binder toggle all the way to the top. So this entire block right here, let me show you the IDE again. We move this entire block to the top and use it sequence as a custom binder. And then above all of this, so above the search field, yeah. We have this thing, custom binder, and if not custom binder, then you get the option of searching for target. Let's see. Okay, there we go. Yep, now you just get your custom binder sequence or the target sequence. Let's see what that looks like if we run it again from the start without any previous state. Okay. We can just search for progesterone, select a binder, go through all of this. That works fine. Yep. Perfect. B, H, and L chain. Actually, let's link them in this order. Generate those linkers. FGFR4, A, B, cargo sequence, B chain. This is looking good. Yeah, this is looking good. However, if we decide that, no, we want a custom binder instead. That's an issue. That should not be visible. Yes. And not custom binder. State.custom binder. Toggle. Perfect. You can say chain A, chain B, create those linkers, which I guess that wasn't necessary right now. We can attach these things. We can enter a cargo sequence, E chain. We want detection tags, 3x flag and flag tag. I think that's correct. Binder tag TMD protease, binder TMD protease, and PRS and cargo. Yeah, perfect. Okay, very nice. And this is disabled and not available. Awesome. Wonderful. Yeah, it just works. What happens if we create fret sequences? We get this sequence with the chain A binder. We get this with the chain A binder. We get this one with chain B and this one with chain B. Perfect. Yeah. Okay. Nice. It works. Awesome. So we can push these changes really quickly. Was there anything else we did, or was it just this? So yeah, custom binder. Move all of that. Change this stuff. New input part for that, and I think then it's just down here the one change where it creates the new thing depending on this. Yep. Okay. Wonderful. We can commit this with. I think there was an issue on GitHub. No. So, okay, so first of all, this closes number 41. Also, it closes custom binder. Was this not an issue that existed? Oh yeah, okay, I guess it's just this entire thing. 41. Getting a message. Nice. Okay. No, all of these other issues are not related to that. Yeah, okay. So it just closes 41. I guess link to Bindcraft. Custom binder input. Push that change. Nice. We can continue now, and now actually let's tackle the big one. creating a Python package which can do this. Um, so I guess, yeah, I've never done that, so I don't exactly know how that works. Let's see. There's probably a good guide, right? Okay, guys, let's read this together. This tutorial walks you through how to package a simple Python project. It will show you how to add the necessary files and structure to create a package, how to build the package, and how to upload it to the Python package index. If you have trouble running the commands in this tutorial, please copy the command and its output, then open an issue on the packaging problems repository on GitHub. We'll do our best to help you. Some of them commands require a newer version of pip, so start by making sure you have the latest version installed. I think I do, but sure. Yeah, already the latest version. Okay. Oh. Yeah, okay. This tutorial uses a simple project named example package your username here. If your username is me, then the package would be example package me. This ensures that you have a unique... You know what? Actually, I'm going to create a quick new project for this. Just to test this out. Because I don't want to mess up this existing stuff, I guess. I mean, I guess it would be fine. Although, yeah, I think a new package might not... A new project might not be too bad. Yeah. So, Mesa Designer Python package. Okay.